Hello, hello. I'm Mr. Monty. Welcome back to Algebra 2, Unit 5, Polynomials. This past week, we've been dividing given polynomials by some sort of linear binomial. Let's just recap this example here. If I take x minus 2 and divide it into this polynomial, we're going to actually end up with a remainder. Hopefully you remember, if we do get a remainder other than 0, that means that this is not one of the factors or the zeros of this polynomial. But let's just take a look so we can refresh our memory. 3x squared times an x, 3x cubed. 3x squared times a negative 2 gives me a negative 6x squared. The key to avoiding mistakes is when we go to subtract, minus times a minus is a plus. So we add 10x squared plus, bringing this down, the 0x. Now, the next step, how many times does this x go into 10x squared? 10x times. 10x times x gives us 10x squared. 10x times a negative 2 gives us negative 20x. Again, when we subtract, this minus is distributed to both of them. Minus 10x minus a minus 20 gives us the plus. 20x, bring down the 10. And we'll have the 20x plus 10. How many times does x go into 20x? 20 times. 20x minus 40. When we go to subtract, minus is distributed to both of them. Minus 20x minus a minus 40 gives us a plus. When we add it down, we get that positive 50. Now, we haven't discussed very much about the remainder theorem. But watch this. Kind of interesting. This value is the same value as when we take a positive 2 and plug it into the original function. F of 2, 3 times 2 to the third power plus 4 times 2 to the second power plus 0 times 2 plus the 10. That's 3 times 8, 4 times 4, 0, 10, 24, 16, 0, and 10. We get 50. So this is actually called the remainder theorem. When we go and do the long division, if we get a 0, no remainder, that means that what we divided into it would have been a factor or one of the zeros. In this case, it wasn't. Well, this week we want to take a step forward and learn about synthetic division. Synthetic division is a shortcut. It's a little bit quicker, and in a lot of cases, less messy. All these minuses and changing signs, we can make a lot of mistakes. So let's do the same problem using synthetic division. We're going to leave this down here to remind ourselves if we do get exactly the same answer, this positive 50. One of the most important things, just like in the other method, we need to make sure we have all the placeholders recognized. In this case, when we're using synthetic division, instead of x minus 2, we're going to use the value that makes it 0, positive 2, with kind of like a reverse upside down division sign. Now we're going to use the coefficients only of what we had before the polynomial. So try to remember, that was 3x to the third, so we'll have a 3, 4x squared, 4, got to have that placeholder, 0 x's, and 10 digits, 10 ones. First step on synthetic division, just take the first coefficient and bring it down. Then we're going to multiply. 2 times the first coefficient, get a 6. Just add them straight up, 10. 2 times the 10, add them straight up. And then 2 times the 20, add them straight up. And lo and behold, we do get exactly the same remainder. Synthetic division seems to be quicker, faster, a lot simpler, with a lot less opportunity for mistakes. So a lot of students really enjoy using synthetic division. Our answer represents the same thing, where we started out up here with 3x cubed, 4x squared, 0x, and the 10. Our output, 3x squared plus 10x plus a 20 with a remainder of 50 divided by the original x minus 2. If this would have been one of the zeros where the remainder was 0, this would have been also a factor where we could have gone to the next step to help us get all of the zeros or factors of this original cubic. So now you're going to have a handout with approximately 12 problems. I'd like you to do 6 of those using the synthetic division method and the other 6 using the long division method. We'll see you tomorrow if you have any questions.